Hi guys, BuildZoid here, and so this guy left this comment on the MSI Z590 the MSI Z590 motherboards video, and I thought, hey, that sounds like an interesting idea. Let's try do that. So I've already done one take, and then I made some choice comments in that video. There was also towards the end of the video, I realized there's a comment right under his that I thought was kind of dumb, so I just didn't want to keep that one in the video. So yeah, this is take two. Um, Hopefully this turns out better. Oh, and also hopefully much shorter, because I've actually now run the comparison between all three boards, and I do have an opinion. And my opinion is the Asus Maximus 13 Hero is dumb. Because here's the thing. So the three boards are the Maximus 13 Hero for $500, the Meg Z590 Ace from MSI for $500, and the Gigabyte Z590 Aorus Master for $409. So the first thing you should notice is this thing is $90 cheaper. So if you buy the Master instead of the other two, you can go and spend your money on things that actually make a difference, like a better memory kit, or a better cooling system, or a better power supply, or a better, like, literally anything else in your computer. You can upgrade it with the money you save, or you can just, like, keep the freaking money. You know, like, who has ever felt bad about having more money? So, you could just keep the $90. That's also always an option, you know. You can just have $90. Not you could, not sure what you're going to do with them, but you can figure that out at a later date. Anyway, but there are differences between these boards that sort of, reflect the pricing differences. So, the biggest difference between these three motherboards is that, or arguably the biggest difference between these three motherboards, is that two of them have Thunderbolt and one of them doesn't. So the two that have Thunderbolt are the Maximus 13 Hero. There's two Thunderbolt ports over there, but as far as I can tell, there are no display inputs on this motherboard, so I don't think you can do display pass-through on those Thunderbolt ports, because I have no idea how you're going to get the video signal from your GPU into the Thunderbolt ports, considering there's no video inputs that I can find. So yeah, if you need display pass-through on those Thunderbolt ports, I don't think this motherboard supports that, but I'm not an expert on Thunderbolt. Basically, my interest in Thunderbolt is other people are interested in it, and therefore I've kind of tried to do some research on it, and I'm very lazy, so take that with a massive grain of salt. But anyway, so as far as I can tell, this doesn't do display pass-through. The MSI board, on the other hand, does have two DisplayPort inputs. So this actually has like full-blown, display pass-through on the Thunderbolt ports. Yeah, so these two have Thunderbolt, and the Gigabyte board does not have Thunderbolt at all. It's just not there. So, that's your rear I/O difference there, is this doesn't have Thunderbolt at all. And you also only get one Type-C connector instead of two. If you care about that, well, then, if you want the Thunderbolt, I guess you go with the MSI board, is my assumption. In terms of networking, the differences are this has dual 2.5 gig LAN. The Master has 10 gig of Quantia LAN, and this has 2.5 gig LAN, single. So if you only need one LAN port, you can save money with Gigabyte, or you can or if you also still need the Thunderbolt, you can get the MSI. And if you need dual LAN, Asus makes a motherboard that has dual LAN and costs less than the Hero, and just so happens to be very similar in by all other metrics is extremely similar. It's called the Strix Z590E. This also got dual 2.5 gig LAN. It's also way cheaper than the Hero. In my opinion, the best argument against the Maximus 13 Hero is this board right here, not the other two, because this is way cheaper. And again, it's like if you save a bunch of money, like, you can go and spend it on things that actually make your system faster instead of a more expensive motherboard. Because fun fact, a terrible memory kit on an amazing motherboard is still a terrible memory kit. So, if your plan of getting a high-end motherboard is so that you have great memory overclocking support, well, first you should make sure that you actually have a memory kit that's worth overclocking. Just saying. So Yeah. Anyway, and $120 actually goes a long way in RAM. Like that gets you if you have like the difference between $100 kit and like a $220 kit, like that is a potentially very large difference. Like you could go from 16 gigs to 32 on that. Or you could go from 32 gigs to like if you go from $200 to $300, you could go from 32 gigs of like relatively like you can honestly get at around 250 you can get like a set of cheap Samsung B die in a 32 gig configuration. Well, with $300 you can get an expensive set of Samsung B die. Hopefully it'll overclock better. um, Anyway, or you could get a better cooling system for your CPU, or any number of other things could be improved in your system. So yeah, like this in my opinion right here just makes the Hero really really dumb. But anyway, let's keep going through the rear I/O differences. So yeah, so that's the networking differences. All three motherboards have BIOS flashback functionality and a clear CMOS button, right? So Gigabyte has their Q Flash Plus back here, and then a clear CMOS. MSI has the exact same thing, except in different order, which infuriates me to no end because like what I've ended up doing is like the motherboards I have to label where the clear CMOS button is because I don't remember who has it in which order. So anyway, MSI has clear CMOS up top, whereas Gigabyte has it down, which like not really a problem if you have one motherboard. Big problem if you're me and constantly swapping between motherboards because it's like, oh, I wonder where the clear CMOS button went. Um, and then Asus actually also has the clear CMOS button up top, like MSI does. Is it like MSI or is it like Gigabyte? Like MSI does. Yeah. So they also have the clear CMOS button up top. But fun fact, the Strix E also has a clear CMOS button. How convenient. um, Anyway, so the rear IOs between these boards are extremely similar, and then this has 8 USB ports. Like this has 8 Type A USB ports. This has 8 Type A USB ports. This has 8 Type A's, and this has 9. Now I'm a sucker for Type A USB ports, so obviously I like the way Gigabyte has this set up. Also, I should have mentioned at the start of this video that MSI and Gigabyte both send me review samples of motherboards. Asus doesn't. Okay, so. Yeah, that's awkward, isn't it? Um, like, I wish they would send me review samples just so I wouldn't have to feel like. But the thing is we're gonna go through just a bunch of different metrics here. That, in my opinion, like the thing is, in my opinion, the biggest argument against the freaking Hero is the Strix. It's not the other two boards because yeah, like this just doesn't do all the things the other two boards do. Or well, this is so much more expensive than the Master. The Master really is kind of an awkward matchup for these because of the price difference. Um, anyway, so that's the rear I/O as far as I'm concerned. Um, I guess a lot of people might be interested in the power delivery differences. So this is a 7+1 phase. Yeah, 7+1 with 14+2 power stages, 90 amp power. Wait, that's the E. Damn it. They even look the same. Like, I'm sorry, Asus. You need to figure out how to make your products more different. Anyway, yeah, this is 14+2 on 90 amp power stages. I mean, 14+2 power stages, and they're 90 amps each. Wait, are all of them 90? I'm pretty sure the +2 part is 70 amps. But anyway, this is a 7+1 phase VRM. The phase count doesn't really affect you. It's just how the VRM is controlled. And honestly, you can get perfectly good voltage regulation out of a 4-phase if you bend over backwards. They're like that, like yeah. So the phase count is just kind of like that is a. It's kind of like comparing how many cylinders a car engine has, kinda. But like you can still have a V6 that puts out more power than a V8. Honestly, you could have even like an inline 4 that puts out more power than a V8 if the V8 is especially bad. So yeah, that's actually kind of a pretty good analogy. So yeah, it's just like the phase count is a means to an end. It is not the goal in and of itself. Okay, like it is very easy to build an incredibly high phase count VRM that also sucks. Like, that's not that hard to do. like the thing is there's generally like for a given like level of output current and level of like voltage regulation, there's generally a sweet spot phase count where your cost and performance sort of match up very well. Um, Though if you buy an expensive enough motherboard, who cares about VRM manufacturing costs? So then you just kind of get all of the phases with some vendors. So yeah, anyway, so this is a 7+1 with just two power stages shoved into each phase. The reason why you would put two power stages in each phase is it doubles your current handling capacity. So yeah, this can handle a ton of current. This right here has a... I'm just going to check. I can't remember. Yeah, 16 power... Wait, is it actually 16? Wait. It seems to have a display output for once, so did they add an iGPU phase? I should have had the document open. Either way, like this VRM is going to be... This VRM is comparable. I like this is how much I care about the details. Like honestly, like you know, like as much as I like to talk about all the details of how VRMs work, it's like a lot of the time they just don't matter that much. And in this case, this is one of those cases where they really don't matter that much. This is also 90 amps more power stages, comparable number of like I think it's 16 power stages for vCore, so this might run slightly cooler. Um, but other than that, like, and even it actually probably runs at the exact same temperature. It'll depend more on your like case airflow and the heatsink design than the actual power stages in like in this comparison. Um, and this is on 18 power stages. Um, and this runs a bunch of doublers. And actually, the MSI board should also be using a bunch of doublers. Um, the funky thing about the doublers that both Gigabyte and MSI are using is that the last time I've actually seen those doublers running in phase doubling mode is like 990FX. Normally on modern motherboards, they're run in synchronous mode because that gives you better transient response. But you do still get like the thing about synchronous mode with the doublers that these boards use is that they'll actually do per channel current balancing. So you sort of get this like like you get the current balancing capabilities of like what a true 8 phase, like a true 16 phase would be capable of, but you don't get the 16 phase interleaving functionality, which depending on the input filtering doesn't matter. And I'm serious about that. Like, depending on how the input filtering is designed, it doesn't matter at all. Like, I've done tests where a 14-phase VRM had the exact same input ripple as a 7-phase because the 7-phase just had twice as many capacitors on the input. So, yeah, we might technically be producing more switching noise because there's a lower phase count, but we've also got twice as much filtering for said switching noise. So it works, like, in the end, it works out to be basically the same thing. So that's kind of that. It's just like depending on how the motherboard manufacturer wants to, uh, configure their VRM. There's a lot of different ways to achieve the same result. Is what I'm trying to basically get at. So between these three boards, technically this has the most power stages, and it should probably run the coolest. But at the same time, functionally, I consider them all equal. So yeah, like I don't really like I do not consider the differences in how the VRMs on these boards are designed significant. They're also extremely similar to the VRMs that Asus, MSI, and Gigabyte ran on their Z490 boards. And I did actually manage to test transient response or voltage regulation on the Z490 boards. Which is mostly a function of transient response if you're testing with an actual CPU in the socket instead of like a DC load, because CPUs are very, very, very noisy. Yeah, so for the most part, they perform basically the same. Because this is basically a bigger version of the VRM that the Z490 Master had. And that was pretty much tied with the VRM that actually this is like a bigger version of the Z490 Extreme VRM, and the Z490 Extreme was tied with the Maximus 12 Apex that I was testing, and this is like a slightly smaller version in a way. This is in a way a smaller version of the Maximus 12 Apex VRM. And so functionally, I consider like this should have basically the exact same voltage regulation performance, and this should also And so between these two boards, I do not consider there to be a functional difference. And then this should be like, so the Z4, the predecessor of this board, the Z490 Unify slash Z490 Ace, had ever so slightly more voltage overshoot than the Gigabyte and the Asus boards, but voltage overshoot is basically completely irrelevant from an overclocking standpoint because, like, unless it's ridiculously high, it doesn't really endanger your CPU in any way, and it wasn't. It was like tens of millivolts higher than what the Gigabyte and Asus boards were getting. And in terms of undershoot, it was the same. So this right here is just like, yeah, so I consider this a tie. Where, this is like, well, this is measurably worse by an irrelevant amount. Or the predecessor of this was measurably worse by an irrelevant amount. And also, MSI has added some PCB layers, which could actually lead to better voltage regulation than on the Z490 boards, which were 6 layers. So honestly, those measurements don't necessarily apply that well to this board right here. So yeah, ultimately, at the same time, I don't think an extra 2 layers is going to make the board drastically better. So I think, like, it might make this now tied with the other 2 boards, which is like, okay, great. So now everybody is equal as far as I'm concerned, these should all be completely equal. And the reason I say should is because you never know until you test that they definitely are. But I'd be very, very, very surprised if there was a significant difference between these 3 boards in terms of voltage regulation or VRM operating temperature. And by significant difference, I mean like one of these boards running at like 90 degrees while the other 2 run at 60. I think that I'm not sure which one's going to run the coolest. If I had to guess, it might be it might be the Gigabyte. Like, this technically has the most, this almost certainly has the most surface area, so this should probably run the coolest. But yeah, I'm not sure. So I'm really not sure on that. And honestly, as long as all 3 of the boards are running, like, even if they were all running under like 90 degrees, I'd be fine with it. Like, they could all literally be at 90 and it's just like, that's fine. They shouldn't be. They should all probably end up somewhere in like the 60 Celsius range, depending on test conditions. If you test in a case with a lot of airflow, I wouldn't be surprised if they were running in like the 50 range, potentially even lower. But yeah, so basically VRM-wise, I consider them equivalent, and I spent way too much time to get that point across. Memory overclocking-wise, it gets super awkward, and I'm just not going to judge them on that at all, because MSI thinks their motherboard can go up to 5600, or MSI claims that their motherboard can go up to 5600, Gigabyte claims that their motherboard can go up to 5400. Well, at least this is accurate. That matches my experience with 10th gen on this board so far perfectly. So they're not lying about that part. Yeah, I hope they fix that. I really hope they fix that, because that was like such a jarring disappointment when I tried that. Anyway, and then Asus claims that their board goes up to 5333 with 11th gen. Right, like Asus is claiming 5400 for 11th gen. I mean, Gigabyte is claiming 5400 for 11th gen. Now, the annoying issue with this is that we don't know how they're measuring this, because you can't buy memory kits with XMPs of 5400 or 5333 or 5600. So I don't know what their test criteria for these memory frequencies are. And so, the claims are not comparable. And therefore, I have no interest in, like, saying MSI has the best memory overclocking or Asus has the best memory overclocking or Gigabyte. And memory overclocking just in general is a horrible mess, because depending on which exact memory kit you're using and which memory chips are on that memory kit and what PCB that memory kit is built with, you can, like, just because a motherboard is extremely good at overclocking Samsung B-die doesn't automatically also make it really good at overclocking Micron sticks or Hynix sticks or even other Samsung sticks. Imagine that. Yes, you can actually get motherboards where it's like some Samsung memory sticks work way better than other Samsung memory sticks just based on the die type. And because of that, it's just kind of one of those things where, like, unless you have all three motherboards and then a stack of memory kits, this is super difficult to judge. Um, but as long as you're like staying away from the as long as like I would dare say that as long as you stay below like 4800, the differences in the memory overclocking are going to be basically non-existent, or at least very minor. Also there's also the whole issue of like some motherboards are actually really good at like raw memory frequency, but then like they have timing issues. Like you won't be able to do 1T command rate above like 3600 megahertz. That's a really common wall for 1T command rate. At least it used to be. I don't know if Z590 still does that, but on Z390, a lot of motherboards, if you were on 1T command rate, they would only go up to like 3600. And also, another issue is, depending on which exact BIOS version you're using, the memory overclocking behavior can be drastically different. Like, drastically. We're talking like, 6 ticks of any timing, or 500 plus megahertz of clock speed. Like, basically, yeah, I'm gonna. So for the memory side of things, I'm gonna go with the same judgment that I went with for the VRM. Well, actually, no. With the VRM, as far as I'm concerned, these are equal. With the memory, it's kind of like I have no idea. They're probably all somewhat decent into the mid 4000 range, and then above that, I have no idea. Absolutely no idea. Um, from past experience, MSI's frequency, like MSI in my experience, has had the most flexible memory support and is the easiest to clock high frequencies. Not necessarily the best timings, though. But definitely for like daily use, I've liked MSI's motherboard. For daily settings, MSI motherboards have kind of been my favorite in terms of ease of getting stuff running, especially if you are buying like weird memory kits. Um, Whereas with like Asus, my experience has been like, yeah, if you're running certain Samsung VDI kits, it works amazingly well. But other memory ICs not necessarily as well supported. Um, but yeah, like this is one of those things that ideally you just want to test. So, um, yeah. Anyway, and then Gigabyte's memory overclocking has been kind of like, well, some motherboards are absolutely amazing and like the best thing I've ever worked with, and some of their motherboards are like, whoa, this sucks. And there's no pattern to it as far as I can tell. It's just like, yeah, sometimes Gigabyte makes like some of my favorite motherboards of all time, and sometimes, well, no, not necessarily. Like some of my favorite, they do make some of my favorite motherboards, and sometimes they make motherboards that I don't like, not with a 10-foot pole. Um, so yeah, it's like that's kind of all over the place. Anyway, so that's kind of the memory thing where, like, for Z590, I think that'll be most, like, it depends what frequency range you're going into and how low you're trying to run the timings and what, like, yeah, as I said, it just depends on too many variables, so I'm not going to try to judge them on that. What else is there? I think that's kind of it, isn't it? We've talked memory, VRM, rear I/O. What else does a motherboard have? Oh, right, we have buttons and postcodes. Well, they all have buttons. I mean, they all have power buttons. They all have postcodes. This has a safe boot jumper. This has dual BIOS. And this, no, this has the flex key. This has a power button and a postcode as well. This has the flex key button, which allows you to reconfigure the reset button. Like normally it works as a reset button, but you can reconfigure it to be like a safe boot button. And I think it has a few other functions. Gigabyte has since copied that functionality. They have a button down there which can be set up to be safe boot or boot to BIOS and that kind of thing. I've not yet tested how well that works, but I'd assume it worked like I. So yeah, I've not yet tested how well that works. But honestly, like for a very long time, most motherboards didn't have safe boot, so you can probably live without that. Also, this has voltage read points hiding right above up above the DIMM slots, which aren't really that useful to under most circumstances. But hey, maybe you want voltage read points for some reason, then you have them. And MSI's Ace, this does have voltage read points as well. And it does have a safe boot jumper, which I'm a big fan of because you can just wire up like your case's reset switch to the safe boot jumper, and then bam, you got safe boot. Um, and then also this has, I do believe, yeah, this does have dual BIOS. So Gigabyte and MSI have dual BIOS here. Um, and dual BIOS is super handy in my opinion. Like it's great if you want to test differences between two different BIOSes for like memory overclocking or something. You can flash one of your BIOS chips to the new BIOS and keep the the other chip on the old BIOS, and then you can just very quickly run comparisons between two different BIOS versions. Um, so yeah, I'm like dual BIOS is cool in my opinion. And what else is there? I guess M.2 slots. Um, I think the manual is going to be best for taking a look at that, which I do actually have the manuals for all of these boards opened up. Yeah, actually, um, yeah, so there. See? Set this button to boot on safe mode. I tried to test that, but I tried to test that with a 10th gen chip, and the memory overclocking on 10th gen, as you saw from the specifications page, was yeah. So I'm not sure. Like I think it was mostly recovering because I was trying to run 3600 and it just wasn't doing it. I'm not sure if that was the safe boot button actually doing what it's supposed to, or if it was just the board recovering on its own because I was doing something that currently doesn't work. Um, I really hope they fix the 10th gen memory support. Like it's Z590 is supposed to support 10th gen, so like come on. Um, the thing is, if you're buying an 11th gen, that doesn't really affect you. So I don't really like. So if you're wondering like why I'm considering like taking that so lightly, is like I'm working under the assumption that you're considering a Z590 board if you want a Z 11th gen CPU. Because if you're buying a 10th gen CPU, Z590 doesn't really get you any extra features. I guess unless you want like the 10 gig LAN or the safe boot. Well, no, you can get Z490 boards with safe boot. They're just not made by Gigabyte. Um, so yeah, that's kind of that. Anyway, so this has three M.2 slots. If I'm not mistaken, this has four. Yeah, that has four. So the MSI board has all of the M.2 slots, I think. And this has, is this the Strix? This is the Strix. We want the Hero. The Hero has, that is not the part of the manual I want to be in. The Hero has also got four. Oh, so Gigabyte seems to not have as many M.2 slots. So I guess if you want a bunch of M.2 slots, you want to get an Asus or a MSI board. Yeah, also, flex key button to reboot system. You can also configure the button and assign quick access features such as safe boot or turning off RGB. Anyway, so yeah, Asus has four M.2 slots. Gigabyte only has three. So I guess that's all. That explains a bit. Like that explains a lot of the price difference as well. I guess. There anything else that I'm missing? Wait, how many does this have? This also looks like it has four. Does it have four? So yeah, it does have four. Well, that's a. Why is the layout so different between them? Like, why is that? Oh well, either way, both of them have four M.2 slots, so that's what you're looking for. Yeah, so that's kind of the thing. So the Ace makes a lot of sense if you want the Thunderbolt. If you don't care about the Thunderbolt and you also don't need four M.2 slots, then the Master is a great way to save like $90. And then the Hero, in my opinion, is just kind of really pointless because the Strix E exists. And the thing about the Strix E is that the only thing this board, actually no, there's like three things that this motherboard is missing. It doesn't have a flex key button. It doesn't have Thunderbolt. And it doesn't have... Well, I don't think it has the DyeSense measurement circuitry. But other than that, because the VRM on this, as far as I'm pretty sure the VRM on this is 70 amp smart power stages, which perform basically the same as 90 amp smart power stages. So with 14 plus 2 of them, functionally no difference. Right? Like, again, this is another one of those, yeah, I consider this VRM equivalent. So, yeah. So hopefully that covers this comparison right here, where it's like the Hero, in my opinion, just doesn't make sense. Because if you want an Asus motherboard with like 99% of the features of the Hero, there's the Strix E. It's even got the dual freaking LAN. Like, which is such a weird feature for, in my opinion, for this price point. But yeah, like, you've got your dual LAN, you've got your 4M.2 SSD slots, you've got the same, basically the same VRM, you've got the same memory support. You got Wi-Fi 6E, you've got a clear CMOS button, you've got a BIOS flashback button, you've got a postcode. Like, what's the difference? Right? Like, yeah, I guess your vCore monitoring on this motherboard is going to be somewhat worse than on the Gigabyte or the MSI board or the Hero, but like, that's not really that big a deal. Under most, you can work with socket sense voltage sensing. It's not ideal, but you can still work with it. It's not a catastrophe. And then with the Master, I think, like, the main reason to get the Master, I guess, is the 10 gig LAN. It does, I didn't realize that, like, the 4M.2 slots thing would be so common on Z590. Like, because yeah, I did not realize that that was going to be a pretty common thing for other motherboards to have. So when I saw this, I thought this was really cool. Then again, I ultimately don't care about M.2 slots, like, at all. I still don't have a single M.2 SSD. So to me, this is fine. If I was choosing a Z590 board, I wouldn't, like, the thing is, MSI also makes this lovely thing right here. I mean, this horrible looking mess right here. I almost said, well, the thing is, the feature set is lovely, but what they've done to the heat sinks isn't. What they've done to the heat sinks is the opposite of lovely. But basically, it's got a postcode, and I do believe... Oh, wait, no, it doesn't have the safe boot jumper. Does it? I can't remember. Honestly, you can live without safe boot. Like, the postcode is way more useful than like, order of importance, postcode, then safe boot. Like, safe boot is like the next step up on things that make overclocking memory easier. And MSI boards are actually really quick to recover a lot of the time, at least on Intel platforms. On AMD platforms, it's a mess. But on AMD platforms, like, all of the motherboards are a mess. Like, sometimes you get an F9 code, and then 3 resets later, it resets itself. And sometimes you get some other post code, and then it doesn't. And then you're just kind of stuck with clear CMOS, which sucks. But anyway, so yeah, ultimately, if I was choosing a Z590 board, I'd probably go with this horrible thing. Man, I hate that color on those heatsinks so much. Like, why? Like, why? Off yellow and off purple. Lovely. Exactly what we needed. Like, so many colors to choose from, and they go with this. But I do like the feature set a lot. So this is almost like, yeah, this is basically what I would go for. So anyway, I've kind of ruined this, haven't I? Is there a cheaper board with a postcode? Well, this has a postcode. Actually, this might be a... Well, admittedly, the VRM on this does actually need the fan, probably, so... Like, there's a fan in that VRM. And it almost certainly needs it. So, you know, I guess they figured that problem out. And it does have a postcode. What kind of memory support like... Anyway, so yeah, I'm getting off track here. The comparison was hero versus ace versus master. The answer to that comparison is like, if you like Thunderbolt, ace. If you like if you want 10 gig LAN, master. And if you think the Asus hero is good, then get a Strix E. There, that's my solution to that. Um, so yeah, that's my answer to this question. And yeah, that's it for the video. Thanks for watching. Like, share, subscribe, leave any comments, comments and questions down in the comment section below. And if you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts, stickers, posters, you know, the usual YouTuber merch. Both of them help out immensely with running the channel. It's, you know, like Patreon and Teespring is basically how I'm able to buy a lot of the motherboards that I can't get can't get manufacturers to send me. Not that I'd be asking for a hero anyway, because I do think it's really dumb. But I wouldn't mind trying out a Dash E to prove my point about how pointless the hero is. No, that's exactly like that's the best reason not to send me either of those, isn't it? It's like, oh no, he's gonna ruin the sales of the hero board. Don't send him an E. Um, anyway, yeah, that's it. So thanks for watching, and goodbye.